Hi, welcome to physics lesson. Today we go to chapter 5.2, Faraday's law and magnetic flux. For chapter 5.1, you have learned the concept of induced EMF and induced current. You have learned Faraday's law and Lenz's law. Now, for 5.2, we have calculation. Okay, that is to find out the value, the magnitude of the induced EMF and induced current. Now we start with a term magnetic flux first and flux density. Okay, magnetic flux 磁通量. Okay, the unit for magnetic flux is Weber, WB. Okay, let's look at the definition. The magnetic flux, we use a symbol phi. Okay, we call this phi. Phi is defined as B times A. Okay, now you see here the figure 5.28. Magnetic field pass through the coil. Okay, and the coil has an area A. Magnetic flux 磁通量 is defined as B times A. 即係幾多 B field 穿過去個 area 度，咁啊 B 乘個 A 就係個 magnetic flux 咯。The unit is Weber, okay? Now we will define as the magnetic flux should be normal to the area. Okay? If there is an angle which is not normal, not 90 degrees, so we have to resolve magnetic field into vertical components. Okay, so here we may have cosine theta. Actually, it depends on the angle given. Okay, maybe sine theta as well. And magnetic flux linkage. Okay, now suppose for the coil we have n turns. Okay, so the total magnetic flux through the coil n turns will be n phi. Okay. That is MBA. The magnetic flux linkage, the total magnetic flux is MBA. Okay? Magnetic flux density. Now, it's a name which means magnetic field, B field. Okay? Now, as we know, phi equal to BA. Okay? So B equal to phi over A. We call this magnetic flux density, magnetic flux per area, magnetic flux density. Okay, the unit would be Tesla, B field, right? Tesla, or Weber per meter square. Okay, it can be Tesla. You have learned this in chapter 4, magnetic field unit, and also magnetic flux Weber per meter square. OK， 咁有啲同學可能會唔識㗎，見到啲題目 magnetic flux density 唔知問乜㗎，其實就係問 B field 啊。OK， now here is the calculation B times A. Okay, flux linkage N phi MBA. Okay, unit is Weber. 幾多magnetic field lines 穿過去啊，磁通量。嗱 ，this is the most important part in chapter 5.2. Now for Faraday's law, actually we can calculate the induced EMF. Do you remember 5.1 Faraday's law? Induced EMF is directly proportional to rate of change of magnetic flux. Rate of change of magnetic field. Okay, that is what you have learned in chapter 5.1. And also induced EMF is directly proportional to a rate of the conductor cutting magnetic field lines. Okay, this is C version only, but for the A level version that it would involve a calculation with the equation This equation is given. Okay, induced EMF is equal to minus delta phi over delta t. Okay, sometimes, well, actually, we only interest in magnitude, so sometimes we would neglect the negative sign. The negative sign means oppose. Okay, 對抗佢，所以有個負啊。Because current due to induced EMF produce an opposing first change to work against the first change, which cause it。好啦，咁對抗佢，咁所以嗰個負係產生嗰個 induced current 係對抗佢產生 B field 對抗佢，所以我呢度定義咗個負。OK， 咁好少會用嘅，不過都個負，因為我要計個值為主。嗱有 magnetic field 穿個圈，咁就係 B 乘 A 啦。咁如果我係知道個 induced EMF 係正比於嗰個 rate of magnetic field 嘅 change 喎。好啦，咁既然正比啦，咁可唔可以即係我有冚條式出嚟計出嚟咧？咁可以啊，就用呢條式計出嚟啦。就係個 magnetic flux 嘅 change 隨時間就係個 induced EMF 啦。OK， induced EMF is defined as minus delta phi over delta t, rate of change of magnetic flux. Okay. Induced EMF in chapter 5.2, it will be rate of change in magnetic flux. Okay, that is delta phi over delta t. Okay. Now we can have calculation for this. Now maybe I'll give you one example. If a coil is an area equal to say 1 meter square, okay, enter into magnetic field, okay, and then suppose the entire coil will enter into the B field in 1 second. Okay, and the B field say is 2 Tesla. Okay, so what is the induced EMF and induced current? Suppose we have R equal to 1 ohm. Okay. So in this case, you have learned this in chapter 5.1. So the current will flow in anti-clockwise direction. Do you agree? Okay, anti-clockwise direction. Because you can create a out of paper B field to oppose the incoming of the magnetic field. Okay. And we have equation induced EMF equal to minus delta phi over delta t. Actually, we just need to find out the magnitude. Okay, so what is the change of magnetic field? What is the change of magnetic flux? Originally, no magnetic flux passing through, so 0. Okay, but finally, you know all the area are inside the magnetic field, so it will be B times A. Okay, the time, delta t. So substitution, B field 2, area 1. Okay, time is 1 second. So the voltage, the induced EMF is 2 volts. Okay, and with resistance 1 ohm. So we can also find the current, which is 2A. Okay, and it is an anti-clockwise direction. Okay, maybe you can drop it down in your textbook. This is a very simple example to use the equation. Okay. So we're so happy we can know how to solve the problem for the coil and find the induced EMF and induced current. How about what? If we cut through B field lines, so how can we calculate? Okay, now maybe we find some place to try an example. Now maybe we have a rod here. Okay, the rod has a length of L. Okay, if we enter magnetic field, suppose the rod has a speed v. Okay, I want to find out the equation for the induced EMF. Okay, in terms of B and VL. Okay, so here we need to know how to derive the equation. Suppose the rod move to the right hand side for delta t. Here, delta t. So the length here would be v delta t. Do you agree? Constant speed v delta t. Okay. So you cut through area here. So we can use the equation delta phi over delta t. What is the magnetic flux change? It would be B delta A, okay, over delta t. And delta A is this area, yellow region. So it will be L V delta t. Okay, so if a rod moving in a magnetic field, inside magnetic field region, we have the equation BLV. Okay, BLV. You need to know how to derive this equation. OK， 咁如果支棍快啲嘅個 B field 嘅，咁個 voltage 就高啲啦。係啦，條棍長啲嘅，咁個 induced EMF 又大啲啦。B field 大啲嘅 induced EMF 大啲。OK, three factors BLV. OK， you can find this in 244. OK, the derive V delta t area. Okay, BLV delta t over delta t BLV. Now, these two examples are very important. Now, maybe you can try trap-on 3. Okay? Which coil has a maximum flux linkage. Okay, there is NBA. And then find the flux if you rotate. Okay, and then the rod. Find the induced EMF and also direction of induced current. Okay, trap-on 3. So when you have done the answer, you have tried, you can check the answer. Trap-on 3 answer C. Okay, 4.83 times 10 to the power minus 3 magnetic flux, so Weber. And the watt. You can use either Lenz's law or Fleming's right-hand rule. You have learned this in chapter 5.1, right? Fleming's right-hand rule, so you know current goes up, okay, along xy, or you can think this as a loop. So there will be an increasing in magnetic field into paper, so you should create an paper magnetic field, so anti-clockwise direction. Okay, still the current from y to x. Okay, and induced EMF, BLV. Okay, that's all. Now more examples about Faraday's law. 好啦，轉個圈都會產生電啦，因為個 magnetic flux change 啦。咁呢度唔再長講啦。咁飛機係個鐵嚟㗎，咁我 cut 副地球嘅 B field line 都會發電，係咪？咁有發電就冇電流嘅，因為佢唔係 complete circuit 啦。好啦，咁呢度可以自己睇下。 example X 就重要啲，係啦。咁不過都係要自己睇下，係啦。咁頭先講個 opposing force 啦，咁所以咧，如果我要均速嘅話咧，佢要有個 external force 去做㗎，先可以均速㗎。係啦，如果唔係咧，就會有個 opposing force 會減速㗎。OK， 你可以都要能量角度去諗嘅喎，即係佢原本個動能變咗電能啦，咁所以你要做 work done 咧，先可以 keep 住佢個動能唔好減少。OK 嗱 ，search coil 嗱if there is a change in B field, we can use search coil to determine. Okay, search coil is only consists of many circular coil. Search coil, okay. So 5,000 turns, okay, small area. Okay, it can be used to determine the varying B field。有咩用啊咁？譬如你啲電牆裏面有啲電線，啲電線而家行緊 AC 噶嘛，行緊 AC 即係佢產生個 changing magnetic field 啦，用你個 Weyl rule 嚟睇到，一時間 out of paper，一時間 into paper 係咪？所以用 search coil 咧，我就喺 detect 到 B field change 咧，就會 induce EMF 咧 ，induce current 咧，咁我知道電線喺邊個位啦，係啦，通咗電嘅電線，咁我知道邊個位嘅重要啦。如果唔係我轉個牆嗰時有機會轉爛，轉到條電線噶嘛，咁我咪會觸電咯。好啦，咁呢度咧就個 syllabus out 咗好多 ，cut 咗好多啊。你只要知道咧佢個存在性得㗎啦，係嘛？即係如果我呢度駁咗個 AC。係啦，咁我電流有一刻係咁樣啦，咁呢一度咧就會係呢度係into paper B field 啦，呢個 out of paper 啦，係咪？但係佢係 AC 嚟嘅喎，AC 即係會轉啦。咁咧，如果電流咁樣嘅時候咧，咁個 B field 呢個變咗 out of paper 啦，呢個變咗 into paper 啦，係啦。所以個線圈咧會呢一個 search coil 咧會 experience 咗個 changing B field。咁佢就可以 detect 到個 changing B field 咧，知道咧有條電線喺前面啦，係啦。咁當然有啲嘢注意㗎啦，你嘅 search coil 咧要放平嘅，咁個 magnetic flux 先會多啲㗎嘛。咁啲 B field 咁樣穿過去多啲嘅 magnetic flux。如果斜咗咧，即係傾斜咗咧，就個 magnetic 會細咗嘅。OK。嗱 checkpoint 4 search coil。OK 嗱 search coil actually you know it detect varying B field. By varying B field we have induced current. Okay, we have constant induced current. So how can we have a larger value? Okay, so you have the equation NBA over T. Okay, because you know induced EMF is delta phi over delta T. So N turns, so NBA NBA over delta T. Okay, so what is the answer? Maybe you can try. Okay, so the answer is all of them. Okay, induced EMF and delta phi over delta T and BA, okay, delta T. Number of turns increase. A increase. So yes. Okay, area increase. Oh, sorry. Number of turns increase. Area increase. Okay, yes, okay. And then last one. Magnetic field change at a higher rate. So it will be delta B over delta T increase. Okay, this part. Okay, so induced EMF would also increase. Okay, any problem? You can try you can try practice 5.2. I will suggest you to try question 6, 5. This is the answer. Okay.